Okay, in this video, we're going to take a look at the quotient rule for differentiation, which is kind of similar to the product rule. This time, the thing we want to take the derivative of, surprisingly, is a quotient. So we've got a function on the top in the numerator and a function on the bottom in the denominator. And then here you see we have the formula. We take whatever that function in the bottom was, write it down unchanged, multiply it by the derivative of the top minus the top times the derivative of the bottom. Whole thing gets divided by the bottom squared. I'll erase those so you can see that better. This is a formula you're going to have memorized. And I kind of wrote out what's going on in my head when I'm thinking of this formula. This is kind of how I have it memorized. Kind of a quick shortcut: bottom, derivative of the top, minus. Don't forget that's different. When we had the product function, it was, or the product rule, it was plus there. For the quotient rule, it's a minus. Minus the top times the derivative of the bottom, all over the bottom squared. So let's apply this new quotient rule here to this first example. We want to find the derivative of this function. We are looking for f prime of x, okay? So the top function this time, the one thing I'm going to call the top, is 4x squared minus 3, and the bottom is 2x plus 1. So to apply that rule, we start with write whatever you had in the bottom. Don't change it. Just write it down exactly as you see it. Multiply that by the derivative of the top. Here, the derivative of the top is 4 times 2, which is 8, x to the 1 less power. The derivative of minus 3 is 0. And then we have a subtraction. This time we write down the function that was originally in the top. Don't change it at all. Multiply that by the derivative of the function you had in the bottom. The derivative of 2x is 2. The derivative of 1 is 0. And then that whole thing gets divided by whatever function you had on the bottom. No derivatives here. Oops, sorry. 2x plus 1 quantity squared. Okay, so that's the application of the quotient rule. We do have to do some simplifying, so go ahead and distribute that 8x. So we get 16x squared plus 8x. Have to be a little bit careful when we distribute back here. Don't forget that's a minus sign in between those two terms. So we are really, in essence, distributing a negative 2. Okay, so that ends up being minus 8x squared plus 6, whole thing divided by 2x plus 1, quantity squared. Okay, then final step would be to combine any like terms you have up there in the numerator. We have a 16x squared and a minus 8x squared. So that leaves us with 8x squared plus 8x plus 6, whole thing over 2x plus 1, quantity squared. You could expand the denominator. You could multiply out that 2x plus 1 squared, but I don't think there's any need to. I think that is a good final answer. Okay, let's try another one. I'm going to zoom out just a little bit, make that a little bigger. There we go. Okay, so here again, we have a function in the top and a function in the bottom. So to find that derivative, dy dx, we're going to have to apply the quotient rule. So we start off by writing down whatever function you see in the denominator, multiply that by the derivative of the numerator. It is a subtraction, and then write down the numerator, multiply that by the derivative of the denominator, whole thing divided by the denominator squared. Okay, then go ahead and do some simplifying. Up here in this first part, we're going to have to FOIL to expand that out. 14x minus 35 minus 6x squared plus 15x. And then be careful back here again because of this minus sign and this negative 3. So if we want to, we can change this both to plus. 2 minuses give us a positive, so we're really just distributing that 3. Plus 3x squared minus 15x plus 36. Whole thing stays over 7 minus 3x squared. And then we look for those like terms again. We have an x squared here and an x squared there. So minus 3x squared. We have a 14x, a plus 15x, and a minus 15x. So that just leaves us with plus 14x. And then with our constants, a minus 35 and a plus 36. So that just leaves us with plus 1. Still over that same denominator. And that would be our derivative for our second example. Okay, one more example here before we look at a different type of problem. Again, we're going to have to apply the quotient rule. We've got one function in our numerator, the top, one function in the denominator, our bottom. But before we apply the quotient rule this time, I'm going to rewrite that because we've got that 2 over x. This is actually a complex fraction the way it is right now. And we want to rewrite this as 3 minus 2x to the negative 1 because then we can more easily apply our differentiation rules. Okay, so I didn't do anything to change it yet. That's equivalent to our original function. And then I'm ready to take that derivative. Okay, so again, top and bottom. Okay, so the quotient rule says write down the function you see in the bottom, multiply it by the derivative of what you see on top. The derivative of 3 is 0, and then here we get negative 2 times negative 1, x to the 1 less power, minus, write down your function from the top, multiply it by the derivative of the bottom, whole thing over the bottom squared. Okay, then we have to do some simplifying again. We'll distribute up here at the front, so we get 2 times, remember x cubed times x to the negative 2, we add those exponents, so that ends up just being 2x plus 18x to the negative 2. Watch your minus sign. Oops, I meant to highlight that, not to scribble on it. Watch your minus sign there when we distribute. So we're really distributing a negative 3x squared. So we get minus 9x squared plus 6x. Again, adding those exponents, negative 1 plus 2. Combine your like terms. So we just have the negative 9x squared, but we can combine those two x's. 2x and 6x gives us 8x. Oh, I'm going to go ahead and resolve that negative exponent while I'm at it. And even though we started with a complex fraction, we really like it if our final answers do not have a complex fraction in them. So let's go ahead and we're going to multiply both the top and the bottom here by x squared, because that's going to get rid of that complex fraction. So our final answer would be negative 9x to the 4th plus 8x cubed plus 18 all over x squared times x cubed plus 9 quantity squared. Okay, again, we want to practice the problem where we need to find the equation of the tangent line. We've done this a few times already, so we know to find the equation of a line, we need a slope. And to find a slope, we need a derivative. So we need to, sorry about that. We need to find the derivative. See if we can stop jumping around of f of x. Notice here that we are going to use our quotient rule on this problem to find its derivative. So the quotient rule says take the denominator, multiply it by the derivative of the top, subtract, take the top, multiply it by the derivative of the bottom, whole thing goes over the bottom squared. Then we go ahead and simplify. We want to distribute that 2 And over here, our coefficient that we need to distribute is just a 1, so we're really just distributing that negative sign. So we get minus 2x minus 1. And then combine like terms, the two x's knock each other out, and we get negative 3 over x minus 1 squared. Okay, this little formula, this derivative, can give us the slope of any tangent line on that equation, but we want the slope specifically at the point 2,5. So we're going to take that x coordinate and plug it into our derivative. So f prime of 2 is negative 3 over 2 minus 1 squared, which is just negative 3 over 1, or negative 3. So we now have a slope and we have a point. We can use those two pieces of information to find the equation of our line. You can either do that with slope-intercept form or point-slope form. Pick whichever one you prefer. I'm going to use point-slope form. That's my preferred method. So I would have y minus y1 equals m negative 3 times x minus x1, which is 2. We'll distribute that negative 3 and then add 5 to both sides. And there's what we're looking for, the equation of our tangent line. And let's take a look real quick in Desmos just to get a visual understanding of what's going on in that problem. So here is our original function. I went ahead and graphed it for you. That was that rational function we started with. And remember, we were looking for the tangent line at the point 2,5. So there's our point of interest. And the equation that we found for that tangent line was y equals negative 3x plus 11. So there you can see our tangent line right at that point 2,5. So graphically, that's what was going on in that problem we just worked. Okay, one more example. In this one, we want to use the information they gave us, given below, to find f prime of 3 for the functions defined. Okay, so rather than giving us formulas for these functions or equations for these functions like we're used to, we're just going to stay in function notation here and apply our derivative rules that way. So here we need to find f prime of x. Okay, anytime you have a constant times a function to differentiate it, it's just the constant times the derivative of that function. Notice we don't know what g of x is, so we don't actually have to differentiate it. We just use our derivative notation. Minus h of x, well, the derivative of h of x is h prime of x. Okay, that's the derivative. That's all we have to do here. Except, one more step. We need to plug in 3 in place of x. So we want 3 times g prime of 3 minus h prime of 3. And these two things are values we just look up in the little table they gave us at the beginning of the problem. So g prime of 3 right here is negative 4. Minus h prime of 3 right here is 2. So we get negative 12 minus 2, or negative 14 for our final answer. Oh, and there's one more. I must have deleted it, so I'll just write it in here for you. Part B, a different f of x. What if instead f of x was defined as g of x divided by h of x? And again, same directions. We want to find f prime of 3. So first step, we have to differentiate. We have to find f prime of x. And this time, notice this is a quotient. It's g of x divided by h of x. So for the derivative, we really just need to write out that quotient rule that we've been practicing. The bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. One last step, we actually want f prime of 3. So rather than write it all out again, I'm just going to look it straight up on my table. So h of x, that means h of 3. that is equal to -3. G prime of 3 is -4 minus G of 3, which is 1, times H prime of 3, which is 2, whole thing divided by H of 3 squared, so that's -3 squared. So we get -3 times -4 gives us a +12 minus 2 over -3 squared is 9. So our final answer here would be 10 over 9. And that's it for this video.